On the section talking about particle diagrams and net ionic equations, question 1 says, what is a net ionic equation? So this is going to be an equation that only includes ions that actually took place or that actually participated in the reaction that took place. So only includes ions that actually reacted. That's how I'll say it. So things that like changed on either side of the equation. A spectator ion is going to be ions that did not participate in the action. I'm going to say in the reaction, I guess. So they are spectators. They're just standing there kind of doing nothing. So they're unchanged. So unchanged on both sides would be your spectator ions. So, for example, if I have the reaction between ammonium sulfide and cadmium nitrate, remember that in a double replacement reaction, the two compounds are going to switch partners. So I have NH4 that's going to partner with NO3, and I have CD that's going to partner with S. And when you rewrite your new compounds, you have to re-crisscross their oxidation numbers, and your cation should always go first. So NH4, my ammonium, is going to go first, NH4. It has a +1 charge normally, and if it's bonding to nitrate, that one normally has a -1 charge. So when we re-crisscross them, we get NH4 and O3. And then I have cadmium bonding to sulfur. Cadmium, according to this, has a +2 charge, since that 2 would have been crisscrossed. So it would be C, D, S. So then we need to figure out what is actually happening in this reaction. So they traded partners, yes. However, if my reactants are both aqueous, which it says down here, so aqueous reactant, what that means is that I have NH4 with a +1 charge and sulfur with the -2 charge, and I have cadmium with a +2 charge, and NO3 -1. Okay, so I have all of these ions. They're dissolved in water, so we can show that on my particle diagram by saying the same thing we did up above, where the positive hydrogen end would go towards this. So surround that with solute particles. Same thing here, positive hydrogen end is around my negative thing. And then this one would look like that. So I didn't put the dots on there just for the sake of time and getting through this. But you should be able to show them dissolved in water. So I have 2 free-floating ions for each reactant. After they react, if a reaction truly occurred, then I don't just have all these free-floating ions. Something new has to have been produced. So if I look up NH4NO3 on my solubility chart, nitrate is one of our ions that is always going to be soluble. There are not exceptions. So when you see nitrate, what state of matter is this compound that it's in going to be? Is it solid, liquid, gas, or aqueous? Aqueous. And then I have CDS. Sulfur is down here in the insoluble section unless it's bonded to one of these, and it's not. So what state of matter would this be? Solid. So then that means in terms of your product, what you have is this is a new thing that is formed. So my CDS is going to be a solid product that precipitates out of the solution. But because my NH4NO3 my ammonium nitrate, is still aqueous. That means it's going to be dissolved in water just like it was before. So I'm going to have NH4 plus ions and NO3 minus 1 ions floating around in the solution with the water dissolving them just like it did on the reactant side. So keeping that picture in mind of what's actually going on in the equation, let's first balance our equation. So start with the easy stuff. We haven't balanced it yet. Just like before, you don't need to write a 1 if the coefficient is going to be just 1 because that's not actually going to change anything. I have 2 NH4s on my reactant side. I only have 1 on my product side, so I need a coefficient of 2. That takes care of my ammonium and it takes care of my nitrate. I have 1 cadmium, 1 sulfur, 1 cadmium, 1 sulfur. So those coefficients would all just be 1s. So far, so good. I'm going to change my color. Okay, now this part, you just methodically go through the reactants and products and write the overall ionic equation to show me every single ion that is present when the reaction is taking place. So if my coefficient here, I'll put the 1s just since there's blanks. If I have 1 NH42S, the first thing that I have is an NH4 plus 1 ion. But I don't just have 1 of them, I have 2 of them, and I can tell because of that subscript. That tells me that I have 2 of these things. So I'm going to use a coefficient of 2 to indicate that I have 2 of them. So I've taken care of that one. That's good. Then I have my sulfur. How many sulfurs do I have? Just 1. So it's going to be sulfur, and it's an ion, so -2 ion. Because it's been crisscrossed, and if you look up sulfur on your periodic table, that is its oxidation number. That is being added to 2 more ions, my cadmium, which is Cd, and we already identified that it has a +2 charge. There's only 1 of them. That is being added to 2 nitrate ions. I can tell there are 2 of them because of the subscript, so I just convert that into a coefficient. Now I'm on my product side, so I'm going to draw my arrow to show that now I'm on the product side. I have 2 NH4s, so 2 NH4 plus 1 ions. I have 2 NO3s as well. Plus, I have this that's a solid, so it's not actually going to be ions on the product side. If you show it as ions, that's okay as long as you remember that it's a solid and you indicate somewhere else in the same question that it is a solid. So here, just for the sake of showing it in the exact same way, I'll put the ions here, but knowing that when these get together, they're going to form a solid. So -2. And I only have 1 of each of those, the cadmium and the sulfur. So once you have all of your ions that are participating, or all the ions that are present, not even participating, but all the ions that are present, that's your overall ionic equation. Then you go through and you figure out who actually participated in the reaction, who was actually doing something, creating something new, forming an actual product. So since this is the product that's formed, then anyone who was responsible for creating that is part of your net ionic equation. So my cadmium and my sulfur on my product side means I needed to use my cadmium and my sulfur on my reactant side. So I'm going to rewrite this as my net ionic equation with just the things that were part of the reaction. So I have sulfur with a -2 charge, plus I have cadmium, they +2 charge. Those reacted together to form CDS, and that's already balanced. which means that anyone else who's left over in the reaction is what we call a spectator ion because they did not actually do anything. Nothing changed about this NH4 plus 1. I had 2 of them on my reactant side in the aqueous state. I'm going to have 2 of these on my product side in an aqueous state as well, so nothing changed about my ammonium. I have 2 nitrate ions on my reactant side. I also have 2 nitrate ions on my product side. Again, still in the aqueous state. Nothing changed about them. So since nothing changed, they effectively cancel out, and so those are considered our spectator ions. So we showed that down below when we drew that they are unchanged. This is the same thing as this, and this is the same thing as that. So if they stay aqueous the entire time, those things didn't react. So they are spectator ions, they're just kind of hanging out. So sometimes you'll see that they get like crossed out, they get canceled out since they're the same on both sides. That's how you end up with your net ionic equation. Any questions on that part? The only thing I want to say that's different for acid-base reactions, because I don't remember in your homework if you have any of those, is that you will treat, so if we predict our products of this, your sodium and your chlorine get together, and then your hydrogen and hydroxide get together, so you would end up with NaCl, and you would end up with HOH, which you can write as H2O if you want. That is water. I want to remind you what the definition of aqueous means. Do you remember that? If something is aqueous, it means what? Dissolved in water, yes. So dissolved in water. If something is aqueous, that means it is dissolved in water. So if it's soluble and it is in water, it's going to be, or if it's soluble according to this, because this is talking about solubility in water, it's going to be in the aqueous state. Our other options for states of matter are solid, liquid, and gas. So you can be solid, liquid, gas, or aqueous. When you have water as your product, you can pretty much rule out solid unless something happened as far as like a temperature change or a massive pressure change. Your water is not going to be a solid. You can also rule out gas, again, for the same reason. Unless you have a massive pressure or temperature change, you're not going to have water as a gas.
Miss Colson, do you have whiteout?
I might. Let me look. So what state of matter would we call water? Is it aqueous or liquid? Liquid. Good. Okay, so it's not dissolved in water. It is water. So I'm going to call HOH or H2O my liquid. I don't think I have whiteout.
Does anybody have whiteout?
So the reason I'm pointing this out is because this counts as creating something new. So you are basically going to treat water as though it's the precipitate like we had above here. So the HOH or the H2O, it's not a solid, it is a liquid. But that is creating something new. So then when it comes to your net ionic equation, that is going to be the thing that you produced, H2O or HOH. But you'll do everything else in the equation the exact same way. The balancing, the aqueous reactant, putting them together, and then anything that does not react is considered a spectator ion. Yes?
What was the spectator ion for
The top one, the spectator ions were ammonium and nitrate. And then the last one, so I did one example of each. I know I'm like cutting through this. Precipitate reaction was this one. That one is where you have your solid being formed. Acid-base reaction, you're not going to have a solid formed, but you do have water, and so that is an actual reaction taking place. This one, remember the other option for double replacement reactions is when you technically have no reaction. That is what happens when you have two aqueous products. So if I put sodium with nitrate and cadmium or calcium with sulfur, I end up with NaNO3 and CAS. Both of these are aqueous. Remember, nitrate is always going to be soluble, so that's an aqueous solution. And then CaS, sulfur is normally insoluble. However, calcium is listed as one of my exceptions, which makes this aqueous. Oops. Okay, so if I come back down here, my CaS is going to be aqueous. And so if you start with 2 aqueous solutions and you end with 2 aqueous solutions, that means that you just have all 4 of those ions in the solution to start and all 4 of those ions in the solution to end. So you didn't actually create anything new. So your net ionic equation here is that there is no reaction. I'll write that better. But you should still be able to predict the products, balance it, write the overall ionic equation, and then show me what your ions are, draw the particle diagrams like we did above.